So next we look into one of the most powerful productivity tools in AutoCAD, that is blocks. So this blocks is something where you group together different objects at various places in the drawing. For example, if you take a mechanical component, that is if you refer to a bolt or a nut, so it has a common terminologies or application, that is each and every bolt is going to be defined by its major diameter and such. So the basic definition is going to be that, and based on that you can have different varieties of it, but these are all dimensions are all standardized using various norms. So this blocks will help us to create one such set of the basic definition of the bolt or nut and then save it for future use. So to put it back together, a block is a collection of objects that we can associate together to form a single object. So this block, what we can do is we can insert, scale it or rotate based on the requirement in the drawing. Also, we can explode a block, that is we can break a block into its constituent objects, then modify them and then put them back together as a new block. So these are all the different features that we can do in this command. So once we have modified an existing block, wherever this block has been called for in the drawing, AutoCAD will replace everything else of it. So this block conceptually will help us to streamline the drawing process. That is, where and all we can use these blocks is to build a standard library of frequently used symbols, components or standard parts. We can insert the same block any number of times instead of recreating the elements one by one. And next, to revise the drawings effectively by inserting, relocating and copying blocks as components rather than individual geometric objects. Also, we can save the disk space, that is the size of the drawing, by storing all the references to the same block as one block definition in the drawing database. We need not create different instances. We can save it as a single block definition. So that every time when we are creating a block or inserting it, a new instance is created. And then for every such block instance, we can scale it, zoom and rotate it. So these are the major functionality of blocks. So that we'll look into step by step now. So the first thing is where you can see in this block is that in your home ribbon, we have this block title, where we have this insert block, and then we have this create a block, edit a block, and then edit the attributes that are pertaining to a single block definition. And subsequently we also have the definition of the attributes that we look into. That is, we categorize the key features of this block so that can also be showcased in the drawing. So once you define the attributes, you can manage it, and then we can synchronize based on the latest updates, and then we can retain the block attribute definition. And finally, where the base point of the block should be or the drawing should be, so that from there we can insert the external reference or the blocks with respect to that base point. So this is your universal base point. So this is called from the block from the home ribbon table. Alternatively, in the draw command and in block, you can create a block or insert. Also, we have this block palette. So here we will have a list of blocks that are already created and how we can push in or modify it. So this is your block palette. So these are the different ways from which you can approach a block. So towards it, first let us create a base component. So what we can do is, we assume that we have to create a block that defines a hexagonal nut. So towards this, you create a polygon, okay, so with a size of 6, and say the center is going to be here, and it is inscribed in a circle. Suppose the radius of the circle is say So these are arbitrary dimension. Let us just start off with this. So now we have got the polygon here, and now to first the object will be simply chamfered along its edges. So the representation will go by this. So towards this we'll just plot the geometric center and then draw a circle, because once you chamfer it out, this is how it will be viewed from the top angle. So next we have to draw the internal hole, the threaded hole. So let us draw with a diameter of say 8 mm. So this is some random dimension just to show you out. And then there is going to be an internal pitch, that is a threaded element. So in order to represent that, if this circle is considered as an internal element, then 0.85 times of this 8 mm will be the external hole. So that would be the diameter of 0.85 times of 8 mm would be 6.8. So typically this outer circle is your internal thread. So if you recollect the drawing that we had in week 2, so we'll use a similar command. We'll use the break command. So we specify the break. Or something like this. So now this is how you have drawn a hexagonal nut. Okay. So now instead of creating every new instances or just copying or rotating all the things, right now we'll save this hexagonal nut as a individual block. So towards this we have to invoke the block command, the create block command diagram. So one way is we can go using this definition here, create a block definition. Alternatively we can call using this command block. So this is the block definition dialog box. So first and foremost you can type in the name of the block that you are going to create. So let's put in a hex nut. And next we have 3 different columns. The first one is the base point, specifying the base point of the drawing. So either we can specify it on screen or we can pick the point. So when we specify on the screen, then we can make it, or right now let us use the pick point. Say this is going to be the insertion base point for this block. So that has been defined. And next at the settings, what is the basic unit definition of this block? Because suppose it can be any one of this, but your overall drawing can be of different unit setting. So in order to merge those two, then we refer this unit mentioning here, so that we can later refer to what unit was just created and how it has to be scaled or retained. So next we have this object definition. So either we can specify on the screen or we can go by the select objects. So the specify on screen command, what it does is once we close the object box is one where it will prompt for selection of it. But let us retain the same dialog box and then go for the select objects. So now we have to select this object whatever we have to. So this is the hexagonal nut with a chamfered shape. So we have an outer circle and an inner circle and one representation denoting the pitch. So these are all the objects of reference to us. Once all have been selected, click on enter. So now you can see that 4 objects has been selected. Alternatively, you can also use this quick select option. Instead of selecting from the screen, we can use the Q select option to select all the parameters that satisfy to the quick select command. So once it's done there, the command has been resetted. So let us go it again. Yeah. So now you can see that 4 objects has been selected. Next we have option what to do with this original element. If we go on to retain, then once this block has been created, this original object will be still stored as individual objects only. That means that the block will be created, but still each and every element will be individual and they won't be associated with the block element. Whereas if we use to convert to block, then this all the selected objects will be converted to a single block object. And if you use a delete object, it means that once this object has been created and then stored in the memory as a block, this original drawing will be removed from the base drawing. That is, it will be deleted. So this is your option for the specification of the objects. Next, we have the behavior of the block. So first command is your annotated command. As previous, this will annotate the object, and once you select this, you can also have an option to match the block orientation to the layer, so that in the paper space viewports, whenever we call for it, that and the orientation of this block will get aligned. So this will get highlighted only when the annotated option is selected. Next, we have two options, whether to scale uniformly or not. So when you select it, the block reference will be allowed to scale only uniformly in all the direction and not ununiform. Also, we have one more option to allow the exploding. That is, this basic block definition will allow the block objects to be broken into its constituent elements. If this is not selected, then we can't break down the individual elements. So this is the exploding command that can be applied to the block or not. So next we have a general description. So always it's better to put in a description that will help you in a later stage or your colleagues, that will help to understand what is that block definition all about. So here typically right now you can just say that hex nut of major dia of 8 mm. Okay, so something like this. So I'm just putting a random text here. So click on OK. And there is one more option here. So we have the, if you click on that, once you click on OK, it will open the block editor object. So now you can see that we have invoked the block editor object, and now we can vary the block properties in it, certain constraints, certain different parameters, all these things, so that we'll look into the later stage. But by this we can use the block editor object in the creation of the block itself. So thereby now we have created a block. So once you click on insert here, you can see that in recent block it has listed out this image. There is a snapshot of this image that has been stored. So we can click this out, and now you can see that this entire object is now referred to as a single block, and you can specify the insertion point at anywhere. Now you can see that the base of the insertion point has been selected with the base that we have mentioned during creation of this object. So this is how you insert a block. So this insert we have created using this insertion command. So you can also insert this block by in the insert tab. We have this insert block command, or in this block we have the same insert block. So now we can insert the block using this insert command in the home button. So that can also be called by the command insert. So once you click on insert, you will get the palette here, and it will show what is the recent blocks that are available for you. And also we have a dynamic input option. So to specify the insertion options, so we can specify either by the insertion point. Also we can specify what scale it has to be, and specify the rotation, and if there has to be a repeat of the placement, then we can use this and explode command. So we'll look into one by one now. So typically the insertion point we are seeing with this the direct insert command here. So next, if you specify the scale, and next again rotation angle. So in scale, let us say in x-axis it has to be 0.25, and y and z let it be the same. and rotation by 45 degrees. So now we can see that based on that definition, now it has been inserted, and we can also specify the scale, because as we have selected the scale point there, we can specify the scaling dynamically. So if we put it at 0.25, now the next option is to rotate it. So by selecting the tick mark, you can specify the requirement directly at this point. Or if you do not wish to say, and if you want to put it globally here, then you have to update this requirement in this angle. So suppose if this is your point, then you can see that the scaling has been done once and rotation has been done in 60 degrees. So let us again maybe modify this 0.25 with 70 degree angle. Now we can see the same. So this is how you can vary the insertion options by either a dynamic or a preset command. Next, by selecting this repeat placement, you can place multi copies of the same block. And then if you click on explode, it means that the latest object that you are going to place. So now these two objects, now you can see that the block elements has been dissociated into its original compounds, whereas the previous blocks that we had inserted will be a singular element. So this is a explode command that we are using. So if you could recollect, as the object is already a uniform scale based on our definition, we have the same command only, so that we can't specify ununiform scaling. So this is about the insertion of the blocks that have been used. So now we have seen how the blocks were created and how they are inserted. So next, what we have to see is the W block command. So this W block is nothing but write the block to a separate drawing. So here the first thing is that we can specify the source of block. So now you can see that the hex nut whatever we created is available as a block. Or we can also save the entire drawing as a block, or select again. See, this is what was available in your create block command. So you can use this write block to dynamically create a new block definition and then store it out. So let us retain with our same source, that is this hex nut, so that all others are disabled because it is already available in the temporary library. So now we can save this as a separate block command. So it is now saved as a hex nut. So now you can specify the option here, the file name and the path. Now you can see that it is going to be saved as AutoCAD drawing itself. So now if you click on OK, now it has been generated as a individual block. So now you can look for blocks from other drawing, and if you click on that, you can see that that drawing is called as for an entire block. So now we can again go for this insert command. Okay, so as we are using this redefine option, now we can see that that drawing itself has been called for as a new block definition. So this is how this write block command is used to write all or the part of a drawing to a new file, so that you can utilize that from the subsequent applications of the block. So next to this block we have this dynamic block, but to understand dynamic blocks the application better, let us look to one area called as a constraint. So this constraint, what typically it means is you are specifying a relationship between the two or more objects. So to put it in simple terms, imagine the opening and closing of a door. You can see that the motion of the door element is constrained by the axis where you have the latches. So that's how the door is constrained. It cannot go up, it cannot go down, it cannot rotate, but unless otherwise only the axis of the door latches, right? So this is what mean to say that the door has been rotationally constrained with that axis only, and it is not allowed to move in any other axis. So this is an example of constraining the motion. So likewise, we can also give constraints between the objects that are placed into our drawing to ensure that by mistake for any dissociated object, this is a dissociated object and I should not be able to change the shape or modify the relationship. Suppose this, I should not be able to make it like this. It means that this is a chamfer element of this nut. So in that case, it should always be tangential to this border. So this is one type of constraint. So let us see how we can affect this constraint without manually adjusting it. So this is called as a geometric constraint between any two 2D objects or points in an object. So typical examples for geometric constraints is applying a relationship between every endpoint so that they remain coincident with the endpoint of every adjacent object. And next, vertical lines can be constrained as parallel, and then again two lines can be made tangential, or two circles can be made concentric. So those kind of constraints that we have seen earlier also can be applied to here. So let's look into one by one. So our object of interest is this. Okay, so let us remove them all and then click a new object with no rotation, with only one angle. Okay, so this is our object. Now as we had used the explode command, you can see that the objects are individually placed to each other. So this constraint can be clicked by using this. So in order to apply constraints, that you can view in the parametric tab that is available here. So you can see here is the different types of constraints, geometric constraints and then dimension constraints that are available. So we'll just start off with the first one, the geometric constraints. The first feature is the auto constraint, that is based on the given object type itself. When we apply the auto constraint to the object, it will apply the geometric constraints that are already inbuilt into the feature. And next, individually we have these many constraint options. So we have coincident, that is two points will always be coincident to a given point. Then collinear point, that is two lines should always lie on the same infinite line plane. Then we have the concentric. Then this is called a fixed constraint. So it means that we are fixing the all three modes of translation along x, y, z. We do not allow any motion, because in concentric it means that the dia can be different, but only thing is that the all the circles selected should have a common center point. Whereas the collinear also can make sure that the lines can move along the collinear line and it can be positioned anywhere. But this fix, what it does is it frees us all degrees of freedom of this object. So next we have the parallel line, the perpendicular. Then we also have this horizontal constraint and vertical constraint. Then a tangent, a smooth constraint. So this is for a spline element. And next we have a symmetric constraint, then an equal constraint. So these are the various geometric constraints that are available. So typically what we need to say is this inner circle, outer circle and this pitch circle should always be in concentric relation to each other with respect to this center circle. Next, this outer circle should be tangential to all the points. And next, the dimensional sides of this hex nut, this faces should always be equal. And next, and in order to reference to all these things, we can fix this center circle as a fixed element, so that this, with respect to this reference, all other dimensions are applied. So this is the typical constraint that we need to set up. So in order to do that, you can click on auto constraint and then select all the objects that we are interested. We can also go for the settings in constraint. Here you can see that we have geometric dimension constraint. We have all the parameters that were looked into here, and we also have the constraint bar, the transparency, that is, which displays the constraints bar. And next, similarly, we have the dimensional relationship as a constraint that we look into next. But right now, what we are seeing in auto constraint is that based on all the constraint properties, what are the priorities that are assigned to it? So we can modify that priority. So it means that the coincident is the highest priority, equal is the lowest priority. And then also we can specify the tolerances within which the constraint needs to be applied. We have two tolerances here. One, the distance between the objects. Second is the angle between the objects. So by this we can specify the auto constraint option with it. Alternatively, we can also upgrade or downgrade the priorities based on our requirement. So let's say the concentric should be the highest priority, and then the tangential should be the second highest priority. And next, equal side, we'll also apply that. Okay, so yeah, so with this we can try and close it. So when you click on OK, you can see that the constraints have already been applied to it. So this is what meant by transparency. That is 50% the constraint visibility is transparent. So right now you can see that all the selected constraints and all the applicable constraints have been applied. So if you just hover on the object, you can see that now this circle is concentric with this central reference point. Likewise, these two circles are concentric to each other. Okay, so this refers to the first circle and this refers to the second circle, followed which we have the outer circle that is again constrained with the inner circle. So next we have tangential constraints for all the points, and next we have parallel constraints that are applied to opposite points, and also equal constraints applied to the dimensional edges. So this is how you apply the constraints. So what's happening here is, once you have applied the constraints, okay, so suppose let's take this, and if you try to modify this, you can see that it just executes the move command, but rather it doesn't vary the options to it. So why? Because as the constraints are already specified, we are not able to override the dimension. Suppose if we want to move it out, you can see that I'm not able to move the circle, and whenever I move the circle, then the resultant object is a object that satisfies all the given constraints, so that the tangential, equal and parallel constraints are getting satisfied along with the parallel concentric constraint. But this again, you can see that this would not be the requirement of the hex nut. So what we need to do is, we also need to set a constraint between how this dimension can vary, and with reference to this dimension of the circle or the side, we also need to vary the inner circle or the pitch dimension. So that is where we apply the dimensional constraint. So in dimension control, what we are doing is, we are controlling the geometry using mathematical expressions that will include the names of the dimensional constraint, user variables and also functions.